Hello and welcome to Whizz Kids Online. My name is Sophie and today we'll be building a light tracking robot. Now you might remember that in a previous episode we made a brush bot and we were able to make the brush bot move because we created an electrical circuit. So we'll be building on that circuit today to enable our robot to move toward a light source. And today's experiment replicates a behavior found in the natural world called phototaxis. So that is, some organisms move toward a light source and some move away. So you might have noticed that at nighttime, if you put the light on, lots of insects start to buzz around it. That's an example of phototaxis. Now today's episode has a twist. I'll be showing you how to create your circuit, but I won't be showing you how to make your mount. So for example, in our brush bot, the mount is the brush. So things you might want to consider when designing your mount. You might want to think about how heavy your circuit and your batteries are, what kind of surface you'd like your robot to move across, and how powerful the motor is. Can it move a large or a small mount? Now, if you can solve this mechanical problem, I encourage you to take your robot to your local library and show staff at the front desk. We might have a little giveaway for you. But let's dive in. I'll go through the materials that you need to build your robot. So you'll need 2 N-channel MOSFETs, 2 10 kilo ohm potentiometers, 2 photoresistors, 10 jumper wires, a mini breadboard, 2 AAA batteries, and a AAA battery holder. For your mount, you might want to consider using a sponge, so cut it up to size. You could use the end of a toothbrush, so cut the head off, or even a nail brush. Now let's start to build the circuit. With your mini breadboard, you will notice that at the top you'll have letters running from A to J, and then down the side numbers 1 to 17. And these enable us to make coordinates for the little holes that you see on the top. So this very first one in the corner is A1, and that gives us a guide for where we put our wires in. So now I'm going to take you through how to build the circuit. And the diagrams that you see will be available to download online. Take 4 short jumper wires and connect them from E1 to F1, E8 to F8, E11 to F11, E15 to F13. Now you can color code these to represent the electrical current. Typically in electronics, red represents the positive current and black the negative current. Other colors are picked at random. If you want to match your wires to the current, the wire going from E8 to F8 should be red and E11 to F11 should be black. The diagram will show the wire colors according to the current, but if you choose other colors, that's okay. Your robot will still work. If your jumper wires are too long, you can bend them into a U or C shape to make them fit. Double check that your wires are correctly positioned before moving to the next step. Next, we're going to add the potentiometers. Make sure that the metal pins are to your left and insert the first one into holes H1, H3 and H5. Place the second potentiometer into holes H13, H15 and H17. Now we're going to take one of our long jumper wires and connect it to holes F3 and G11. Next, take a medium jumper wire and insert it into holes F15 to H11. Insert your power switch into holes G7, G8 and G9. It doesn't matter which way it faces, but once it's inserted, slide the switch down towards row 17. This is the off position. You might have to bend some wires out of the way to insert your power switch. Next, we're going to mount and connect the first motor. Stick your motor on the top right-hand side of your breadboard with a hot glue gun or double-sided foam tape as shown here. Make sure that the weight at the end of the motor can spin freely. You don't want it to get stuck down by the glue or by the breadboard. Take the motor's blue wire and connect it to E16. Then take the motor's red wire and connect it to J8. Now we're going to connect the second motor to the bottom right side as shown here. Stick your motor onto the breadboard following the same procedure we used for the first motor. Once in place, take the motor's blue wire and connect it to hole E2. Next, take the motor's red wire and connect it to I8. Double check your connections. Use the diagram to ensure that you've connected your wires correctly before moving on to the next step. Okay, once you've checked your work, we're going to insert the MOSFETs. MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. Transistors are used to switch and amplify electronic signals in electronic devices. To insert your first MOSFET, orient it so the writing on the MOSFET is facing to your left and the metal tab is facing to your right. Insert the MOSFET into holes D1, D2 and D3. Take your other MOSFET, orienting it as we did before, with the writing to your left and metal tab to the right, and insert it into holes D15, D16 and D17. It's important that you orient the MOSFETs correctly. If you put them in backwards, your robot won't work. Next, take a long jumper wire and connect it from C3 to C11. Then select a medium jumper wire and connect it from C17 to D11. Now we'll add the photoresistors. The photoresistors will enable the robot to detect light and direct its movement. Place the photoresistor into holes A1 and A8. Place the other photoresistor into holes B8 and A15. Okay, now let's connect our battery pack to the breadboard. Take the red wire and insert it into J7. Next, take the black wire and insert it into J11. If the circuit feels hot or if you see or smell smoke, disconnect the batteries immediately. This indicates that you have a short circuit, which could damage your robot. Okay, now we're ready to turn our robot on. Before you do that, triple check your connections just to make sure that they're all in the right spot. All right, now before we test our robot, we want to make sure that everything is in the off position. So make sure that the switch on your battery pack is in the off position and also that the switch on your breadboard is in the off position. So if your battery pack is on the right-hand side, that switch is down towards number 17, so towards you. Okay, now the first thing we're going to do is position our photoresistors. And we're going to do that because our photoresistors will enable our robot to turn once we put it on the mount. So the one on the right should point towards the right and the one on the left should point towards the left. So you just gently bend them so they look something like that. So once you've got your photoresistors in place, now you can test your potentiometers. So to do that, make sure the dials on your potentiometers are turned all the way to the left, anti-clockwise. So you shouldn't be able to turn them anymore. All right, now we're going to turn our battery pack switch on and also the switch on our breadboard. Now, if you've connected everything correctly, nothing should happen. So don't stress if nothing does happen, that's good. Now we're going to test our front motor here, our right-hand side motor. And to do that, I'm going to turn this dial clockwise. And there you go. It's spinning, excellent, it works. So now I'm going to turn it back down and I'm going to test my other motor. So I'll spin this around so that you can see it. And there we go, it's spinning, excellent. Now I'm going to turn that back off. Okay, so now we have to tune our potentiometers. Now the potentiometers control the photoresistors' sensitivity to light. So when we turned them up, they were reacting to the ambient light in the room. They were detecting just the lights that we have here. But we don't want our robot to be that sensitive to light. We only want it to be sensitive to the light that we shine on it with a torch. So the way that we tune the potentiometers is to first turn it up as we did until the motor starts to spin, and then slowly turn it back down until the motor just stops spinning. So your dial shouldn't be all the way off, but it shouldn't be on enough so that the motor spins. So I'll demonstrate here. So as I turn this here, my motor is spinning, and I'm going to slowly Just put it back down and it stops spinning. And I'm going to repeat this for the other side. And yep, there we are. Okay, excellent. So I've got my potentiometer tuned. So now what you can do is you can test it with your torch. So here I've got my torch and I'm going to shine it on this one. And here you can see that motor is spinning. So once you've mounted your robot, when you shine the light on your left-hand photoresistor, your robot will turn left. And then when you shine it on your right photoresistor, your robot will turn right. And if you shine it on both, your robot will move forward. So thank you so much for joining me today. I hope you have fun building and designing your robot. Maybe once you've got it up and running, you can make a maze or an obstacle course and lead your robot through it. Or you might want to change the circuit so it moves away from a light source rather than towards it. Thanks so much, and I'll see you next time. Bye-bye.